Hmm, what do we have here? This is something new that doesn't show up in the other videos. And in fact, this time I just want to show you a multi-threaded application working. So what I'm going to show you is a little walkthrough of a sample program that I've made. I've made it this graphical program because it's a little bit easier to understand what's going on and you can see where the data changes. So with that said, let's go ahead and dive in, and hopefully you just enjoy this example of seeing concurrency used. So I'm going to go ahead and close this window here, as this is the application that we're running. And let me go ahead and show you or do a code walkthrough of what I've built here. I'll make the font a little bit bigger, and maybe this will be an interesting application for you to play around with, or just again to see concurrency in practice. And I'll ask a few questions along the way. So let me go ahead and start from the top. I've included how to compile this software. Now, as far as doing the graphics output, I'm using what's known as the SFML, or the Simple Fast Media Library. I like using this, and I have other videos on this. If you'd like to take a look, feel free to explore my other resources. So what I want to go ahead, though, is focus on the code here for a moment. I've included some additional libraries here, and I'll explain them as I walk through. But the key thing is that there's 3 global variables keeping track of what's going on in this program. I've got a grid here. That's a vector. And it's just going to hold some values. So if I go ahead and run the program here, we'll see we have a grid that's 2 by 2 in the sort of x dimension and the y dimension. So that's where we're going to just hold some integer values representing what color each of these circles should be. And then I've got my shapes here. Now they're a vector because I want to have the flexibility to create more, perhaps if I want to increase my grid size. And I've made them unique pointers so I can allocate these particular shapes at runtime. And because the SFML library has different types of shapes, it has some polymorphism that we want to take advantage of. That is, and let me go ahead and be very explicit about this, an SF shape here could be of type circle, rectangle, or perhaps other types. So I want to take advantage of the inheritance here so I can draw different types of shape. So that's why I'm making this a pointer, and a unique pointer will also help clean up after itself so I don't have to worry about potential memory leaks. And finally, I'm going to keep track of the state of the program. I have this global is running Boolean variable, because the fact of the matter is when I close the window, I want to make sure not only does my application close, but all of the threads that are also running. So we can talk about this design and we'll encounter some other concurrency primitives such as conditional variables that may otherwise be useful. But for now, this design works. Okay, so the idea is each of the threads is going to run this update grid function. So what that means is while our program is running and keeping track of this global variable, each of our threads is going to sleep for just about 1,000 milliseconds. And then it will generate a random value to populate the grid with. Now I've taken in parameters x and y to represent where, again, in the x and y position. So for example, this first circle here is in 0, 0, here is in 1, 0, here is in 1, 1, and here is in the location x of 1 and a y of 1, where each of the circles are. I've got to convert this 2D value into a 1D value here, so that's exactly what I'm doing. Okay, and again, the idea is each of the threads is able to do some work while the program is running, making this important computation deciding what random color it's going to be. So that's the work that each of our threads are going to be doing. We can think of them as worker threads. They're working on some important external task in our application. Now, you might ask yourself, do I need any locks here? If each of the updates that I'm doing on my grid are always going to be on independent values, that is, well, if I have 4 circles and I'm updating them independently, do I need a lock? Am I sharing anything within this grid vector? I'll give you a moment to pause and think about it. And if you pause and thought about it for a moment, the answer is I don't need a lock here. And this is how we get sort of data parallelism and an increase in our program's output. Now, maybe for this small toy example, it doesn't matter as much, but what I'm demonstrating is you don't need locks if you're always going to be accessing a unique value. So that's the idea with upgrade grid. Okay, so Now, at the start of my program, I just reserve 4 spots for my grid, and then I'm going to use standard fill just to initialize my array to values of 0. And then I'm going to make 4 circles here. And this is where that inheritance, the polymorphism comes into play here, where I can create a circle shape as opposed to a shape. Maybe decide later that they should be rectangles or whatever. But I'll push these back into my shapes vector so I have those shapes available. And then I'm going to launch my 4 threads. And what those threads are going to do is, again, update my grid with the associated X and Y position, representing where that shape is, and continuously update every 1000 milliseconds the value in the grid. Now, again, this isn't a very expensive computation, but it demonstrates our ability to do work in threads while our program continues to execute. Again, updating this shared value here. And again, you might look at this thread here, and I've got prepared here just the help page if you want to look on CPP reference here, just to see that you can put away threads or put them to sleep rather for a given duration. And I like to think in milliseconds for most of my use cases. Okay, so once we've launched our threads here, then we'll create the SFML windows. Again, it's not as important that you understand SFML. You can do this example without any graphics and just print out the values in the grid, and that would be equally interesting. But this was for fun and help you understand what's going on. And then I have my main application loop here. So while the SFML window is open and our program is running, I look out for events. Meaning if I hit the escape key, that means the user is quitting the window, and I should update our Boolean flag and close the window. Otherwise, every frame, I clear the window, and then I run through this loop here. Now, what this loop here is doing is it's constantly setting the position of the shapes. Perhaps I might want to move them around. We don't exactly need to do this multiple times, but perhaps I can move them around here. And then I'm checking for each of my shapes to set the fill color based off of the grid value. Remember, that's the value that's being continuously updated in a separate thread. So again, separate work is going on somewhere else in our program, and we're able to, in our main thread, read the updated values and make the associated changes. So in a gaming context, you might think of this as the main thread loop that's executing, and we have some worker threads doing graphics work. In this case, simulating different colors or deciding the different color in the grid, which we read from and update our shapes appropriately. Then finally, it becomes time to draw each of our shapes and display them to the window. Finally, when we're done, we'll go ahead and join all of our threads at the end if this main program loop is terminated. So again, when is running is flagged to false, then we want to make sure we join all of our threads with the main thread before terminating. So let's go ahead and execute this one more time and see the cool effect of these different threads moving around. Now, if I didn't join the threads here, or perhaps if I joined them early, again, we wouldn't get to the main loop. So this is where I have to be a little bit careful with the program design. Let me go ahead and show all the source code on the screen. I know it'll be tiny, but just to give you an idea of the program flow, where I'm joining all of the threads. Here's my main program loop here that I have. And here's where I actually launch the threads. So from here onwards. Okay, so just to keep that in mind, that I'm launching all the threads ahead of time. They start doing their work. I run the main application loop. And then I also have 4 working threads at any given time during the program, because I have a 2x2 grid in this simulation running. So I think that was pretty cool. And perhaps a pragmatic example for you to think about. 1, do you need locks? What problem are you trying to solve? And how can I actually have some threads executing while I have another main thread executing at any given time? So I hope this was a fun example for you and you enjoyed this. The code, of course, is available for you to play around with, and we'll continue on the series learning about more concurrency. But now we get to see a simple application how to apply threads, modern C++.